everyone. Thank you for joining DataCon LA 2021. Welcome to Data Infrastructure and Security. My name is Hestia, your host, and your co-host today is Idris. We will be moderating the chat and Q&A for you this session. Today we have our guest Alex Silva, Director of Engineering at SecurityScoreCard, and he will be talking about moving from monolithic data platform to a distributed data mesh. Alex is an energetic technologist and a business strategist, passionate about engineering, diversity, and cultural growth. He also enjoys leading teams, writing code, finding value in data, designing large scale systems, and providing a unified product vision. You will probably catch Alex with an athletic bag on his shoulders. He is a bit of a sports junkie and particularly a CrossFit addict who has been known to create an epidemic of fitness and weight loss around him, so beware. Without further ado, I will hand this over to the speaker. Thanks for being here, Alex.
Thank you, Hestia. Am I still coming through? Can you hear me still?
Yes, I can hear
Okay.
it.
Okay, cool. Let me switch gears here. All right, so let's go ahead and get started because we have quite a few concepts to cover today. So the title of this talk really is to talk about data mesh as an architectural paradigm for data infrastructure, sharing data, building data platform, and data sets. So before we get started, let me just talk a little bit about myself. So I'm director of engineering right now at SecurityScoreCard. I spent some time at Pluralsight as well. It's an online learning platform. And also did some cool things both at Rackspace Hosting and Walt Disney World with their reservation systems for dining and park reservations. And if you haven't heard about SecurityScoreCard, they are the global leader in cybersecurity ratings. So what they do, they collect a lot of like public information about companies and would build a digital footprint of a company, and then that gets processed into a bunch of measurements, and then they score a grade letter score about how secure that company is. You can go check it out. It's free to sign up and check out the scores, and chances are your company's there and scored as well. Okay, so let's go ahead and get started. Before we talk about data mesh per se, I wanted to take a little bit of a sidestep and talk more about some of the context, some of the forces that are at play, both in the past and in the present, that kind of shaped the architectural landscape to talk about data mesh and the driving forces behind it. So the first one is to really talk about data. There's this great divide of data that when we think about data, what do we mean by data exactly, right? When we say that we're sharing data, we have data sets, there's two major types of data that we can think of. There's operational data, and those are primarily transactional, encapsulated by microservices. And we'll talk more about these in a little bit, and then there's also analytical data sets, right? And those are more temporal. They have a very different use cases. And if you look at operational databases, you can think of them as a transactional stream of facts, right? They are very close to the services, to the product that originate them. And they're mostly, like I said here, transactional in nature. And they usually reside within your microservices. And if you think about how services share data with each other, right, that's been kind of a pain point for us in engineering to share data effectively. And honestly, I think the hardest part in developing microservices effectively is not so much the technology stack or the APIs, because that's pretty well established. It's really the data, because no service really exists in isolation, right? So it's the whole idea, how do we share data across these different services? So data is usually the sticky point, when you talk about developing different bounded contexts and different microservices. Then on the other end of the spectrum, we have analytical data. And these are very much, temporal data sets. And they have very different use cases than operational data. These are mostly used maybe to train machine learning models, to predict behavior, to analyze historical data. And they have also been historically divided into major components like data lake and the data warehouse. They kind of fall within the same, pillar of analytical data. I'm not going to go into a lot of detail into those. That's kind of outside the scope of this talk. The reason why I'm bringing this up is to really to show this slide and this graph here, that we have these two divergent, data planes. We have operational data and then analytical data, and they're kind of dependent on each other. Then we have these very complex ETL data pipelines in between these two planes that are basically loading data or transforming data from one plane into another. And it's very complex. If you've ever worked with those pipelines, you've ever been in a data engineering team, that's kind of a headache, right? Because data is a moving target. Data changes. And trying to keep up with the schema changes in new fields, it's very, very, very time consuming. And because of that, we've kind of been living in this state of just accepting failures all the time. There's always some errors. There's always some piece of the pipeline that are broken, right? So it's been the status quo for a long time. So that's kind of the little bit of the context, right? So how do we get here? Before we actually talk about data mesh, take another. So now that we know what the problem is, so we have these two planes of data. Their data is a split. There's operational data and analytical data, and they handle very differently from each other. There's also this idea, right, that our data architecture, the things that we thought about in the past that were the proper way to solve this problem, have also contributed to get us to this place that we are today. So, like very broadly speaking, right, we can think of three different generations of data platform architecture. First one, a long time ago, in like your enterprise data warehouse, right? Lots of tables, lots of SQL, lots of very expensive proprietary software, usually owned by a single team, or a business analyst team, or a data engineering team. So very funnel-like. And then your second generation, this is your Hadoop, your Spark, like your early days of Spark, Cloudera, all those like big data ecosystems and their data lakes. And this is really mostly those long-running batch jobs distributed across a cluster, terabytes, petabytes of data across a Hadoop cluster. Also owned, right, by a very specialized team of data engineers. And then the third generation, this is kind of where we are today, though we're kind of departing from that a little bit. This is where you have your streaming, right, your real time. You have your unification of your batch and stream processing with like the stream processing frameworks that we have today, Spark and Flink, Kafka, right, all those. And because of like this different planes of data, right, the way that we have been thinking about data platforms, and like I said before, we have been kind of living or being used to being dealing, right, with these failure modes. So let's talk about them a little bit more to understand, the motivations behind building the data mesh. So the first one really is our data platform. The way that we have thought about data platform has been very centralized and monolithic. It's this monster, right, this beast that's supposed to ingest data from everywhere in the business, catalog, transform those data sets, and then serve a variety of use cases that we don't even know exactly what those use cases will be or what they are. So it's kind of agnostic to think about it like that, right? Because if you look at domain-driven design, if you look at bounded context and microservices, we don't embrace that. We embraced a lot of autonomy. We embrace a lot of distributed ownership. But when it comes to data and data infrastructure, we haven't done that. We just said, hey, let's just put all the data in this data lake and this data platform, and then we'll let this team deal with it. And because of that, right, we have this idea, because of the way that we structured things, our second architectural failure in this mode of thinking about data infrastructure is that the way to decompose a pipeline, because if you think about a pipeline, there's the cleansing, transformation, loading the data, all that stuff is coupled, right, within a single team. So if you think about, lean principles and how we want to structure our teams to be more flow efficient, with this design of a data platform, we actually made things to be more on the resource efficiency side, because now we have even though it's one team, right? So that's good. The bad thing that doesn't really scale too well is that you have these different areas of pipeline responsibilities that are all intertwined within the same team. So there's always a waiting game between, these different areas, the cleansing, transformation, loading, ingestion, that kind of stuff. And then this has led to this idea of having very hyper specialized ownership. It's like that funnel, right? That you have these data sets coming across different areas of the business. They're funneled through a single team. And that team is supposed to be the experts, even though they can't be, but they're supposed to be the experts for all the domain data sets for the organization. And if you think about it, it's kind of a tricky situation to be in because there's really not a lot of incentive for a team to provide a lot of high quality data sets for a data platform that they don't understand what the data is going to be used for. So it's an interesting situation, right? That creates this very siloed, hyper specialized silos of ownership within the data platform itself. So this is kind of the landscape, right? This is how we got to where we are today. So, and then there's this architectural paradigm called data mesh, which it really resonates with me. And I think the goal here is to break a lot of these failure modes that we have seen in the past about the way that we think about data and how we share data. And there's like four major tenets. We'll go over them one at a time. And the first one is really instead of having a single platform that's domain agnostic, right? Data ownership. The idea here, what if we just decentralize that? Instead of having the single team, single data platform team own those data sets, let's federate that ownership, right? It becomes a shared responsibility. Second one is thinking about data as product. And we'll talk more about that means, but think about it kind of as applying the same rules, the same standards that we apply to our APIs, that we apply to our features, and not really thinking about data as a side effect or a second class citizen. How do we level, right? How do we level up data to be at that same level? The third tenet is thinking about a self serve data infrastructure and having that being served as a platform. And we'll talk more about what that means. But basically, the idea here is to prevent duplication of efforts. And then the last one is federated computational governance. And this is one that's interesting to talk about, right? In order, even though we want to embrace this distributed ownership, there should be some global guidelines to make sure that these data sets that we're going to be sharing can be interoperable, right? We can join different data sets from different teams, for instance, as an example. So the core idea here is just domain data ownership, right? So there's three main tenets when we talk about how do we make domains own their data sets. First of all is decentralization. Like we talked about, the whole idea of having this shared responsibility. The best people to own data sets are the ones who are the closest to it. And that creates this idea of locality, right? Because now if there's a problem, if there's a bug, if there's something that I need to fix, all those changes are encapsulated within that team. It's no different than the way we think about an API breaking or some bugs that happen with maybe in a specific piece of the application that we have. In decomposition, right? How do we compose these domains? I mean, one of the ways to think about it, it's just basically the same organizational units that we are using right now to decompose teams into different bounding contexts, into different microservices. That's another way to look at this, that we can just decompose it that same way. And if you do that, we have this idea, right, of we call this a domain-oriented data ownership, as opposed to a domain-agnostic data ownership, which is the model that we have with a centralized data platform. The idea here is that there's no single team, right? There's no more data platform team. Data sets are scattered across the organization. And this domain data teams are responsible for hosting their data sets, not only their operational data sets, and this is the kick here, but also some analytical capabilities for the data sets. So they host both. And what you see here is this dependency now that every domain, right, these bubbles that you have here, the circles are domains, and you can see that they have both endpoints for operational data and analytical data. So it's kind of we go from this push and ingest paradigm that we have right now with the data platform to more of a pull, right, and serve in the sense that we're going to let users who need those data sets to be able to pull them. And having said all that, right, I mean, if you look at this new scenario of things where things are shared, different teams share different data sets, the whole idea behind data and data pipelines, that becomes a shared responsibility. The cleansing, the preparing of data sets, right, the aggregation of data sets, That is no longer a funnel that gets funneled through a single team. That is a shared responsibility for every single domain team. And if you think about, domain, I'm going to go quickly about this. This is because this is not the most important piece of data mesh. This is more of a FYI. If you think about domain, there's two different types of domain data. There's one type that we call source domain data sets. And these are very, very closely aligned with the source of truth, with the team that is responsible for producing those data sets. They're facts, they're truths, they're events, they're entities, they're operational, pieces of information. And that you can think of these like foundational data sets that don't really change that much. And this is perfect to be stored like in a Kafka topic, right? Or anything in a log, anything that has this like factual, historical, chronological way of representing data sets. And then on the other end of that, so you have the source domain data sets. And then on the other end, you have the consumer data sets. And these are more aligned with a specific consumption or a group of closely related use cases, aggregations, right? Maybe you join the source data sets. So it's expected that you're able, as a team, to rebuild these from the source data sets that they came from. All right, so the other super important point, of this data mesh architecture is to really think about data as product, data as part of the product, and as producing direct customer value, right? And like I talked about before, we have been really good into applying product thinking into the capabilities that we have around our APIs. We provide documentation with Swagger, right? Knowledge base, release notes. But every time, it's very rare, at least so far, right, that we have done that same amount of diligence to data. It's always been like, oh yeah, just produce it to a queue or to a Kafka topic and just forget about it. But in order for this distributed platform to be successful, we have to think about data, with that same rigor, the same guidelines that we have for everything else that we do. And there's six major components or characteristics if you think about domain data as product. The first one is needs to be discoverable. And by that we mean it's registered somewhere, right? In a schema registry or a catalog, it's there. So if somebody wants to look up the data sets that are available, they know where to go and it's always there. There's no black box. There's no talking to a team to find out what their data set looks like. It's addressable, meaning that there's a global unique address to it. If you think about consuming data from a Kafka topic, the Kafka topic name would be the address of that data set. There's different ways to think about it. A table name, right, for instance, but it has to be addressable. Trustworthy. There's a clear contract between consumers and producers. Both understand their SLOs, their SLAs, the lineage of the data, how often it gets produced, some basic data quality constraints. Data self-describes itself. It's part of being data, part of elevating data to the level of product. Data has to contain metadata that describes itself. And usually the way to think about that is just schemas, right? If you're using schema register, using Kafka, Avro, Protobuf, some type of format that has metadata alongside with the data itself. Interoperable. This is the governance thing, right? I mean, data to be considered part of the product has to be interoperable, meaning that there are some global rules that data set applies, that it abides to, and it has to be secure. And the security can be very granular. It can be at the Kafka topic level or a table level. But the idea is that the security component of this, right, has to be part of how we think about data from now on, for data to be part of the same rigor, right, the product features have. And how do we do that, right? From an architectural perspective, to think about data as a product and to achieve those six different characteristics, first one is just the code. There's code involved in doing this. Data pipelines for consuming, right? For producing, All these so code in order to produce or to promote data to that level, there's coding involved. And then data and metadata, we talked about it, right? There's computational documentation, there's checks, there's schemas, right? Things like that. And the infrastructure is also part of it. We'll talk about that next, the self-service infrastructure. But the idea is, in order for data to be part of that mentality, there has to be a building, deployment, and running all these data products that we're talking about here as part of that infrastructure and automatically. And then if you think about it, once we have these components in place, right, the data product is really the quantum, the architectural quantum of this whole data mesh. And that's why it's an important concept. If you haven't heard that word before, the architectural quantum, it's basically the smallest or unit of deployable code or architecture that can be deployed independently, separate from everything else, with a lot of cohesion, a lot of functional cohesion, and it's self-encapsulated. And if you think about data mesh, that unit of deployment, it's really the data product, right? It's your domain data sets and applying all these features, these characteristics to those domain data sets. That becomes the architectural quantum of the data mesh, paradigm. And in order to do that, this is actually depends. A lot of different organizations look at this differently. But if you're looking at data mesh, the recommendation, right, is that there's two different roles that would make this process easier. First one is the creation of a data product owner. And this is very similar to a product manager, but you can think about it for the data product itself. Just like product owner is dealing with API upgrades, version upgrades, feature releases. You can think about the same type of role, but dealing with the data product, meaning the life cycle of the domain data sets, right? The quality of the data, the versioning of the schemas, all those different kinds of things, the relationships between different teams, all this stuff would fall into this umbrella, right, of the data product owner. And the data product developer, this is an interesting one. It's you can think of it as a data engineer. It's very much like it, but the idea is that it's more of a full stack, right? So if you have this bounded context, you have these teams, these autonomous teams, this person is an engineer who's also part of that team. And the idea is more, it's almost like meant to be a rotating role, right? But the idea is that you have these data engineers who belong to each one of these domain data teams, and they're able to build, maintain the data products that we're talking about. Keeping in mind, right, this domain data teams that we're talking about, they will probably most likely serve more than one data product. And then, the other tenant, right, that we talked about for data mesh is this idea of having the self-service or self-serve platform or self-serve infrastructure as a platform. And the idea here is to really, lower the barriers of entry. If you want your teams to be bought into this idea of sharing data, of owning APIs, of data products, how can you make that super easy, right? So the idea is if we share a centralized piece of infrastructure that abstracts a lot of the complexity with storage, security, monitoring, streaming, you name it, right? So you can think about it as a data platform that is available as a service for the domain data teams to use. And this is one of the core components of this architecture as well, because we want to avoid that duplication of efforts. And also it will keep us honest, right? Because the whole point here is to develop something, to provide something as a service that is domain agnostic, right? That doesn't cater to a specific domain. It's just a service. And then the last piece of this whole puzzle to kind of put everything together, and this is the most complicated one because it's kind of subjective. There's no like super strict rules around this. It's the idea of governance. And governance, like in the strict sense or in the legacy sense, has been tied to strict rules. Like fields have to be named like this. Every entity needs to have an ID. or primary key, right? Things like this. Topic name should be like this. And the idea here, the keyword is this federated, right? And this is where the subjectiveness comes into place, because the whole concept behind data mesh is to federate, right? Is to distribute that knowledge, that ownership across different domains. So you don't want to be too strict when it comes to governance. It's trying to find that balance, right? How do I leverage? How do I intentionally support this level of independence and autonomy so that data can be owned dynamically by different teams, while also providing some global guidelines so that data sets from different teams are interoperable. If a user is being referred by this team here, the same user is being referred by this other team here, right? That maybe they use the same ID. So things like that. Like what are the kind of the global governance rules that we need to have around the platform? And these are four tenets that help come up with those rules. First one is you really want to optimize for decentralization and autonomy. Respecting that autonomy is super important, right? But there may be some global policies that you need to apply in order for data to be interoperable. The goal here, right, of having this governance is that data sets from different teams, from different domains are interoperable. They understand each other. And one of the things that's super important and that kind of helps, right, with the autonomy is we have to come up with something that's able to evolve. Like a dynamic topology is basically talking about that, right? We add more data sets, we add more fields to an existing data set, and the data mesh itself is able to evolve dynamically. And there's ways to do that with Avro, different schemas, but that's the idea, right? If you don't want to talk implementation, stay more at the infrastructure architectural level. The idea is that whatever governance principles you have in place need to account for that evolving. You have to evolve data sets. And like historically, right, a lot of the governance components that we've had, they usually require some type of human intervention. And the goal here, how can we make that process as automated as possible? All these decisions, how can we automate them? Can we do schema creation based on data sets? Can we create APIs to serve metadata, to create these replication protocols? And that's the goal, is to really embrace automation. So if you think about all this, right, all the things that we're talking about here, and bring it all together in a single graph, it would look something like this. So you have your governance at the top, right, the global principles. And again, the goal there being interoperability, making these data sets interoperable. And you want them to be computational policies as much as you can. You don't want there to be a human intervention. There should be some rules. And those are usually like schema driven. And then in the very center, you have your data products that are produced, they are managed, right? They are created by these domain data teams. Then on the bottom of this architecture, the data mesh, you have your data platform. And we call that a multi-plane data platform because it's really meant to support both use cases. We have operational data that also resides in the data platform, maybe Kafka topic, stream of data. And we also have this analytical data plane that's being served by the data platform. As you can see, there's no ETL anymore between them. The teams, the domain data teams, they absorb that. They absorb any ETL that might be relevant to the domain data sets that they have. And that's pretty much it. I just wanted to say, SecurityScoreCard, we're hiring. So if you want to, this is something that we're working with right now, the data mesh. So if this is interesting to you, and if you want to, I'd love to talk to you if you want to learn more about the company, about the teams, and all that stuff.
Hey, thank you, Alex. Really good presentation. And one question we have for you is on the chat: how do you deal with the dynamic changes in the nature of metadata over time?
Yeah, that's a good question, right? There's usually two types of changes. There's breaking changes, and in those sometimes you just have to make a hard break and have a new version of a topic or a version of a data set, right? But if you use like the right, and I quote right because all this is subjective, right? And there's different ways to solve the same problem. Let's say that you're using Avro schemas in this schema registry. Avril allows for some evolving. You can add a field, right? You can remove a field. You can make things optional. So there's some changes that you can make that will make your data compatible. And if you have something like a schema registry, it will make sure that your changes that you're introducing now are compatible with the older versions of the metadata that you had in the past. And that is the goal, right? The goal for any team, even though it's not always possible, for any data team is to try to stay within that same address as long as possible while changing the underlying schema. But there may be cases, right, that you can't do that anymore, that topic, that data set is completely deprecated. Then you do a V2 of that, of that data set. So it depends, the answer. There's ways to do that depending on the technology that you pick, the infrastructure. There are tools that will help you, like making sure that your schemas are evolvable, they're compatible with the older schemas that you had before on the platform. And it also pays off to, and that's one of the good things as well about having schemas, even though sometimes that word has a very negative connotation, right? We're going to require schemas now, not just JSON. We want schemas. The one of the ways to tackle that negativity is that, hey, it's actually it's a point of introspection for you and your team to think about your data set. What does it look like? What are the fields that we're going to be publishing? And that pays off in the long run, right? Every time they're going to be publishing a new data set as a producer, have that introspection point that you think, oh, how we're going to do this, how we're going to structure this, pays off in the long run for everybody, right? And the whole point for this to work is there's a big component of automation. And in order for that to be automation, data, right, it has to describe itself. It has to be able to go through the pipeline without any human intervention. And the only way to do that really is to have some type of schema, metadata. I don't want to say schema, but just metadata of any kind that accompanies the data sets.
Thank you. Makes sense.
We have another question from Akiva. With automation, wouldn't distributed dash mesh require more than manpower because of added access point and maintenance?
Yes and no. It depends. Not necessarily. A lot of this stuff. Sure, there's not a risk, but there's a potential of data duplication, right, in this paradigm, because now you have multiple teams that may be dealing with the same data sets. Maybe this team over here is aggregating by month. This other team over here by month and year. So there's that possibility. But my assumption is that a lot of these libraries, right, even though they may be owned, the API, the endpoints are owned by a single team, they would be shared libraries, right? I mean, there'll be APIs that every team would leverage for analytical endpoints. So yes and no, right? I mean, it's the same. When you think about splitting up a monolithic team into different microservices, we do that, right? And the goal is, sure, do we need more people? Most likely, yes, we do. But at the same time, we get more autonomy, right? We get the ability to scale now each one of those teams independently from each other. And same thing here, right? That maybe some of these data sets might need more manpower than the other ones, but guess what? It's a localized change now. You don't have to scale a whole data engineering team. You're just scaling that single team. So it's always a trade-off, right? Every architectural paradigm, every architectural proposal that's out there, you're trading something off for other things, with the explanation, the goal being that the trade-off will be beneficial to the team, right, and to the organization in the long run.
We have about 10 or 11 more minutes. Oh, 6 more minutes. Do we have any question? Kiva said, "Thank you for a great answer."
You're welcome.
Any other question?
Alex, I got a question. How do you balance with you mentioned about the monolithic applications and to store data? How do you balance when you design and architect things between data lakes, data warehouses, right, and And there are points of failures because there are ETL pipes you got to maintain for the classic managing, and then you have data lakes where things are coming and streaming. So how do you that's also data mesh. So how do you manage that?
That's a good question. There's really no silver lining. There's no, there's different. It's kind of a one, almost like a case to case, case by case kind of type of scenario here. But one of the things that I like to think about is that in this scenario, right, this data mesh scenario, the data lake, your data warehouse, that doesn't mean they go away, right? This is not the point here. The point is, how do we organize data in a way that it really embraces the same autonomy, the same shared responsibility that we have been embracing with domain-driven design, because we haven't done that, right? And if you think about it that way, your data lake, your data warehouse, that really just edges in this graph. If you think about having this centralized data platform, right, that has both analytical data sets and operational data sets, and if you have these automated replication pipelines kind of replicating those data sets all over the place, there could be these automated jobs. They're pushing data to Snowflake, for instance, right, or AWS. And what doesn't matter, right? And they become just edges in that graph. And if there's an ETL error, most likely it's something wrong with the data set that you're having in the data platform, and then you know where to go to, right? The problem that we have now is if there's an error in the pipeline, a lot of the time that we spent is just debugging. It's like, I don't know, like even SecurityScoreCard now, if there's an error with the scoring algorithm, there's no way to know which team, right? That's why we're moving to data mesh. There's no way to know which team owns that bug, which team should be working on that bug. Now, if you have this clear sense of ownership across these data sets, you have a source of truth, right? A shared data platform that we're all using, then your ETLs are still running to push this data to these like data lakes or data warehouses. But if there's an error, there should be enough information for you to be able to fix it, right? And like I said, the most important point here to bring home is that those are now they become edges in that graph, right? Meaning that you can have the same job that's publishing data to Snowflake, publishing data to a graph database, because the source of truth is there, it's intact. And your data pipelines, right, your ETL jobs, they just become like almost like highways that you get the data that's in a format agnostic, domain agnostic format into a relational format or into a graph database format. And does that make sense? Kind of have the subscription, right? It's kind of kind of like we talked about before. We're the goal is to go away from this push. I'm going to push data to be more of a pull. Right? I'm pulling data and I'm serving, like pull and serve model, where all these like pieces of infrastructure are just edges in the mesh, right, in this graph.
Makes sense. And what are your thoughts about hybrid transactional analytical processing, or with not doing data movement and doing analytics on your operational data, incoming data, without a lot of data movement?
I think it's a risky proposition, but people do it, right? I think it makes sense to have like a clear separation between them.
I see. Thank you.
We have about 2 more minutes. We can stay for a few minutes before we end the session. Does anyone else have any other questions for Alex? Great presentation, by the way. I loved it.
Oh, thank you.
Where are you guys based out of, Alex?
Me? I'm in Utah. The company, we're a fully remote company, but the headquarters is there in New York City.
Okay, New York City. Okay.
Yeah, but I'm in Salt Lake City right now.
Cool.
I do have a question. Is there anything that you could think of, like with data mesh, that you foresee in the future that's not stated in your slide?
A component of data mesh that may not be stated here?
Correct, that you believe it should be.
Yeah, I think there may be some changes One of the things that I'd like to spend more time talking about is the governance. I think there are things there that if anybody wants to dig a little bit deeper into this model, spend some time on that. That is the challenge right now for any company trying to implement this model. This is not a technical problem, right? I mean, we know how to do this. We know how to publish data. We know how to consume data. The tech stack is there. Kafka, Spark, all that stuff is there, whatever that may be. It is more of an organizational problem. Defining the domains, having teams organized around domains. The governance is a big one, right? Because governance historically has been very strict rules, and we don't want that here. We want to be lax, but not too lax. So that is definitely there things are missing because I don't know the answers to those yet because I haven't gotten that far. But I think, like around the organizational components of it, how to organize as a domain data team, and how to govern the data so that it remains interoperable. Those are the two areas that I think that there's some more content upcoming.
That's awesome. There's one more last question. What is one specialized skills that is hard to find in data engineering candidates?
I would say, and this is just it's very subjective. This is for me, right? I mean, it's hard to pinpoint a single skill because sometimes there's a Python team. A lot of the teams that I work with, we use Scala and Spark, a little bit of Python. So it depends on the stack that we're using. But I think as a very abstract way to answer that question, I think being able to think about data sets as arguments into a function. Like kind of apply the same concepts of functional programming into data sets and having those be very deterministic. I think, if you as a data engineer can think about transforming data as a mathematical function that always returns the same value given the same input, I think that's one of the abstractions that sometimes I feel like if more data engineers understood how to think about mathematically about all the data pipeline stages, they would be better engineers. And again, very subjective, right? This is just my answer. I'm sure there's 1,000 out there that could be better answers than mine. But I think having the ability to think about transforming data sets as a functional composition of different steps, because you can take that anywhere, if you think about data like that.
All right. Thank you. Yeah, that makes so much sense. That's why there's a lot of mathematicians that become data scientists. So
Right. Yeah, that's true.
So we are past 5:25, and I will close the session. Thank you, Alex, for your presentation and the attendees for the questions and interactions during the session. You can contact the speaker directly if there are any other questions regarding this topic through the list of this year's DataCon LA speakers. Please provide your feedback using the form provided in the chat box, which I will provide soon. Thank you again for everyone joining today's presentation, and I hope you can gain some insights from the session. Have a wonderful day, and thank you for being part of this year's DataCon LA. And this is our last session. We'll see you again tomorrow.
Bye, everybody.
Thank you, Alex. Have a good night. Bye.
Good night.